This is the second problem we're going to work with wavelength frequency and energy. In this problem we're looking at calcium and we're looking at a Hertz value of 4.22 times 10 to the 14th. Now our equation is still lambda nu is equal to c, c being the speed of light. Okay, and we're looking for the wavelength in nanometers, the energy of one photon, and the energy of 1 mole of photons. So we're actually going to end up with 3 different answers. I'm going to work the wavelength first because wavelength is equal to c over nu, which c is 3.00 times 10 to the 8th meters per second. Nu is given, which is 4.22 times 10 to the 14th hertz, which is seconds to the -1. That means my seconds are going to cancel here, and I will be left with 7.109 times 10 to the -7th meters. Specifically, we ask for it in nanometers, so 1 meter is 10 to the 9th nanometers. We run that number there. We're going to get 710.9 nanometers. We're working with 3 significant figures, so we'll go with 711 nanometers is the wavelength of light associated with this frequency. Now, over here we're going to do the energy. Well, energy is equal to h nu. Since we've got frequency, we'll just use that directly. So h is Planck's constant, which is 6.626 times 10 to the -34 joule seconds. Remember, that's going to be on your constant sheet. Times your frequency, which is 4.22 times 10 to the 14th per second, or seconds to the -1. So the seconds are going to cancel, and we are left with joules. So we get 2.79617 times 10 to the -19th joules per 1 photon. Now we're working in 3 significant figures, so the energy of a photon will be 2.80 times 10 to the -19th joules per 1 photon. So this would be my answer there. But if I want the energy of 1 mole, then I'm going to take my energy of a photon, 2.80 times 10 to the 19th joules per 1 photon, and I know that 1 mole, okay, is equal to 6.022 times 10 to the 23rd. Items, in this case, we're going to have photons, so it's simply a multiplication. So we end up with 1.68616 times 10 to the 5th joules per mole. Again, 3 significant figures, so we end up with 1.69 times 10 to the 5th joules of energy per 1 mole of photons. This is problem 2 on wavelength, frequency, and energy.